Hello, so we're back, and we have, like usual, a nice laptop to repair. So check here, yeah? Acer Predator i7 and RTX graphics, yeah? Predator Helios 300. This is a nice laptop. Pressing the power button, nothing happened. Now, let's read the customer email because this is interesting. So the customer is saying, hello there, Acer Predator Helios 300 2022. Yeah, so it's quite new. Not charging, shutting down on heavy gaming. Looks like the exactly same issue on one of your videos. Now, when you tell me not charging and shutting down on heavy gaming, we all know what is the problem, yeah? But I plugged the charger before on this laptop. Let's plug the charger. This is the customer charger, and the charger is good. I checked it. Okay, it's not charging, but we have no power. Pressing the power button, nothing happened. I mean, how the laptop is shutting down on heavy gaming when actually the laptop is not coming on? So what's going on here? The charger rate is good. I checked with the multimeter. Let me try something, yeah? Let me try with my power supply and see what current is taking. So we have 19 volts on the power supply, plug in the charger, and it's taking like 10 milliamps. And we have the charging light. Huh? Okay, that's strange. And the laptop is coming on. Yeah, the power supply disconnected. 1 second. Because I checked the charger twice, yeah? Go check here. Minus, plus, check on the screen, 19.8. So the charger looks good. I mean, that doesn't mean it's good, but at least we have voltage. We can't check the current, but we have voltage. So plug in the customer charger, and now it's working. Now it's working. And probably now the noise is coming on. Yeah, it is coming on. I hate those random things. Okay, let's open the laptop. Because based on the customer description, we all know what is the problem, yeah? The first MOSFET. Shutting down on heavy gaming means you are losing current. Now, the current doesn't get lost like, evaporating. It's getting exchanged in heat. And a shorted MOSFET, it's a very good example of a heat generator or a component where you are losing a lot of current. Okay, so the laptop, it is open. Wait, what? Huh? Can you see what I see? What is wrong here? I mean, can you spot something obvious? Huh? How? The second MOSFET is missing. But the laptop looks like brand new. Lol, I never seen something like that. Did you seen a SSD with a chip which is looking like a CPU? Did you ever seen something like that? This is my first time when I'm seeing something like that. Huh? Wait, 1 second. Because here we have a M2 drive. Yeah, this is a classic M2. PCA 4.0. So what is this? This is the second SSD? I mean, why is not the same, Strange design, strange. Okay, I will unplug the battery. Let's see what's going on here. Why they removed the MOSFET? I mean, this is against the physics, how this laptop is working. So you have the input. Yeah, check here the input. You have the plus, yeah? This is going to the BK chip, is supplying power to the BK chip. You have inductors, then you have the track, which is coming exactly on the first MOSFET. Then from the output of the second MOSFET, is meant to go here. And from here, you can see, you have probably a current sensor on the other side of the board. But it's not like someone removed the MOSFET. This was not fitted from the factory. So how you can explain something like that? If the first MOSFET is good, let's check. And now I'm curious, because I don't understand how this laptop is working. So the first MOSFET, check on the screen, yeah, 1.2 ohms. So the first MOSFET, it is shorted. Yeah, that's the problem. That's the issue with this laptop. What about here? I mean, from here to here, yeah, 0 ohms. But where is this MOSFET? Do you think it's on the other side of the board? Let's see. Lol. So you can spot, so they are learning. So you see, before, you see those two MOSFETs? So those are in the parallel mode. Before, you remember the Acer Nitro, they have only one MOSFET, but this one has two MOSFETs on the parallel. And then this MOSFET is here. So they fitted only one, because this one was never getting hot. It was never getting burned, sorry. So it's no point fitting the second one here. But here we have two MOSFETs. So which one is shorted? Hard to say. Hard to say which one is shorted. But clearly this is an updated design. I mean, I didn't see before. I seen a laptop with MOSFETs on the parallel on the input circuit, especially Alienware, but not Acer. So if we are lucky, removing this MOSFET and it's not short, we can replace the MOSFET. But can be like the both MOSFETs to be shorted. So let me prepare the motherboard in order to desolder this. Yeah, by the way, I have, if you check the eBay, I listed there the mechanic Kapton tape, yeah? So this one should be able to handle 400 degrees. Compared with my old one, which was only up to 350. It's a good one, Because I remember someone asked on the comments, sorry, what about your Kapton tape? Looks like it's okay. Yeah, you can find it on eBay, on my eBay. Perfect. Now let's remove the MOSFET. Good. So we remove the MOSFET. Let's check for short. And it's still short, you can see. Maybe it's short because it's hot. Yeah, it is possible. It is possible. Let me cool down the board. Yeah, on the other side we have another MOSFET. So if it's hot, then it is possible to show like it's shorted. Let's check one more time. Yeah, it's still shorted. So the MOSFET we removed, it is shorted. Let's see. No, the one we removed is not shorted. Okay, that kind of sucks because we have to take the motherboard out. Okay, so I will edit the video and I will remove the motherboard. Okay, just give me like 1 minute. Okay, so the heatsink is out. Looks like the thermal paste is quite new. Very clean. Check here the heatsink, yeah? Not too much dust here. Okay, so we remove the motherboard. Now going on the other side, yeah. So this MOSFET, it is shorted. Yeah, this one. So let's remove the MOSFET. Perfect. So the MOSFET is removed. Let's solder quickly back the MOSFET from the other side. Yeah, this one. Because this one, it was good. Perfect. Yeah, we have a solder ball here. All good. So we remove this one. Now let me find another MOSFET to solder here. Can I find another MOSFET here on my box? Yeah, this looks like a nice one. But I think this is good. Yeah, it is good. Let's check the data sheet. Okay, our MOSFET, it's able to carry, check here, continuous drain current, yeah? Okay, that's the diode, and this is the MOSFET. 48 amps, you can believe that? And at 100 degrees, 30 amps. 48 amps. So I believe our MOSFET, it's even better compared with the original one. So let's solder the MOSFET. Let's test. Yeah, it is channel N, right? Yeah, N channel. Yeah, that's fine. That's fine. And the original one. So this was the original one, which is shorted, right? It is shorted. Yeah, 0 ohms. Lol, you know what? You know what? This is the original one. 32304. But the original one, it's able to carry like 140 amps. So we have to find something better. And at 100 degrees, 88 amps. Yeah, we need a better MOSFET here. So let me try to find another one. Okay, I found it. Yeah, let's replace it quickly. Yeah, this is a good one. Perfect. So the MOSFET is soldered. Perfect, yeah? And we have one here, and we have one here. Now let's check for short again. Perfect, so we have no short. Now let's put quickly the motherboard back. Okay, so the laptop, it's all back in place, yeah? Let's plug the battery. Because, you know, charging, it's a good sign, actually, the laptop is working. Okay, so we have the power supply. Plug in the charger, check there. We have like 10 milliamps. Let's wait for the pre-charge current. 20, 200, check there. 200, so this is the pre-charge current. And should jump like over 1 amp soon. So we have minus, we have plus 12 volts, you can see, and the voltage is going up slowly. Yeah, the battery has 15.4. You can see the voltage is going up. Let's wait a little bit till the current it will jump over 1 amp. So check there, 2.2 amps, you can see. And the battery voltage is 15.2 and is still going up. So the laptop it is charging and has no reason to shut down on the heavy gaming. Okay, like a general rule, replacing the MOSFETs is usually any MOSFET it will do the job. What we have here, we have a charger like 11 point something amps charger. So probably any MOSFET it will do the job, but also paying attention on the current, the MOSFET we replaced, and on the internal resistance, yeah, because lower internal resistance does mean more power, less heat. But even on this case, what about if I will not replace the MOSFET? Yeah, the laptop will still be fine, but probably the second MOSFET it will die sooner. That's the reason why they fit two MOSFETs here. But looks like it's still they are still dying. Now, just if you have a gaming laptop, the first sign you have shorted your first input MOSFET is not charging. Yeah, that's the first sign. Maybe you'll able to see if it's shutting down on heavy gaming, maybe not, but definitely not charging. You'll spot it. Pressing the power button, the fans are spinning, and the laptop it is working, but it was working even before. Yeah, my MOSFETs are still cold. Yeah, and it's working fine, charging fine. Why the MOSFET died? Hard to say, but from what I can see, like over 2 amps, it's a lot of current for the battery. So the battery is taking a lot of current, probably it's fast charging. And this is one of the reasons why they fit two MOSFETs at the input. Okay, so I'm gonna stop now. I will say thank you for watching. Just like, subscribe, and see you on the next one. Bye.